Welcome to Module 1, Foundations of Responsible Artificial Intelligence. In this opening lecture, we're going to establish the conceptual ground for the rest of the course by asking what it means to develop, evaluate, and govern artificial intelligence responsibly. That word responsibly matters because artificial intelligence is now embedded in systems that influence hiring, lending, education, healthcare, transportation, public administration, security, and many ordinary decisions that people may never see directly. When an AI system recommends, classifies, predicts, filters, ranks, or automates, it can shape opportunities and outcomes for real people. So our starting point is that responsible AI is concerned with both technical performance and the broader human consequences of how intelligent systems are designed and used. A useful way to begin is to separate capability from responsibility. An AI model may be capable of producing accurate outputs, detecting patterns at scale, or automating work that previously required extensive human effort. But capabilities alone doesn't answer whether the system should be used in a particular setting, who might be affected by it, or what safeguards should surround it. Responsible artificial intelligence asks us to examine those questions before deployment, during deployment, and after deployment, because the social impact of an AI system often emerges through use. A model trained in one context may behave differently in another, and a decision process that appears efficient to an organization may feel opaque, unfair, or harmful to the individuals subject to it. This is why responsible AI requires sustained judgment rather than a one-time checklist. Throughout this module, we'll treat responsible AI as a framework for connecting technical design with ethical reflection, organizational accountability, and public trust. Ethical reflection does not mean slowing innovation for its own sake, and it doesn't mean assuming that every automated system is inherently dangerous. It means recognizing that powerful tools require disciplined questions about fairness, transparency, human oversight, data practices, and the distribution of benefits and risks. In graduate level work, this also means moving beyond simple claims that AI is good or bad, and instead asking how specific systems function, what assumptions are embedded in them, what evidence supports their use, and what mechanisms exist for correction when something goes wrong. That level of analysis is essential because responsible AI operates at the intersection of computer science, management, policy, law, and social responsibility. The title of this module also signals that we are working with foundations, not with isolated controversies. Later topics such as algorithmic bias, explainable AI, data governance, regulation, and organizational governance all depend on the basic idea that AI systems are part of larger human systems. They are built by people, trained on data collected from human activity, deployed by institutions, and interpreted within social and economic contexts. Because of that, responsibility cannot be located only in the model architecture or only in the end user. It has to be understood across the full life cycle of development, from problem definition and data selection to testing, deployment, monitoring, documentation, and accountability. That life cycle perspective is especially important in modern technological development because AI systems rarely remain confined to the laboratory. They are purchased, customized, integrated into workflows, connected to databases, and used by employees, customers, patients, students, or citizens who may have different levels of power and information. A responsible approach therefore pays attention to institutional choices as much as mathematical ones. It asks who defines the problem, who benefits from the system, who carries the risk, and who has the ability to challenge or appeal an automated outcome. These questions help us understand why responsible AI is both a technical discipline and a governance concern. As we move through this first module, listen for the recurring relationship between automation and human judgment. Many AI systems are attractive because they promise speed, consistency, scale, and efficiency, and those benefits can be meaningful when the systems are designed and governed well. At the same time, efficiency can create risk when organizations rely on automated outputs without understanding limitations, uncertainty, bias, or the conditions under which the system was validated. Responsible AI therefore asks us to preserve human responsibility even when decision processes become more automated. By the end of this module, the goal is for you to have a strong foundation for analyzing AI systems as technical artifacts with ethical, organizational, and societal consequences. In this first learning objective, we are focusing on the concept of responsible artificial intelligence and why it has become central to modern technological development. Responsible AI begins with a simple but demanding idea. When organizations design, deploy, or govern AI systems, they are also accepting responsibilities for how those systems affect people and institutions. That means we cannot evaluate artificial intelligence only by asking whether it performs a task quickly or accurately. We also have to ask whether the system is being used in an appropriate context, whether its outputs are understandable enough for meaningful oversight, and whether its benefits and risks are being distributed in a defensible way. This is especially important because AI systems now operate inside decision processes that influence everyday life, often in ways that are invisible to the people affected by them. When we talk about the responsibilities that accompany AI design, we are talking about choices made long before a system reaches the public. Designers and developers choose the problem to be solved, the data to be collected, the model to be trained, the performance metrics to emphasize, and the conditions under which the system will be considered acceptable. Each of those choices carries ethical weight because it shapes what the system will notice, what it may ignore, and what kinds of errors may occur. Deployment adds another layer of responsibility because even a well-designed system can produce harm if it is placed into a setting where users misunderstand its limits or treat its outputs as unquestionable. Governance then becomes the ongoing structure that keeps the organization attentive to these issues after the system is already in use. Ethical reflection is essential here because intelligent systems are no longer isolated technical tools used only by specialists. They shape organizations, public institutions, and everyday life by influencing how resources are allocated, how risks are assessed, how services are delivered, and how people are categorized. In an organizational setting, AI might support decisions about hiring, customer service, fraud detection, productivity, or strategic planning. In public institutions, similar systems may influence eligibility, security, access to services, or administrative decisions that carry serious consequences. Because these systems can scale decisions across thousands or millions of cases, even a small design assumption or data limitation can become significant when repeated at that scale. Responsible development therefore asks us to hold two ideas together at the same time. We should recognize what AI can do, including its ability to detect patterns, improve efficiency, support analysis, and expand the reach of complex decision making. At the same time, we have to examine the consequences of how it is used, especially when automated systems affect people who may not understand the system, consent to its use, or have the power to challenge its conclusions. This is where responsible AI differs from a purely technical view of AI development. It treats the system's social setting as part of the system's meaning, because the same tool can be helpful in one context and harmful in another, depending on purpose oversight, data quality, and institutional incentives. This foundation prepares us to examine fairness, governance, regulation, and accountability in greater depth throughout the course. Fairness will require us to ask whether AI systems produce outcomes that disadvantage certain individuals or groups, and whether those outcomes can be justified. Governance will require us to look at the policies, review processes, documentation, monitoring, and leadership structures that keep AI development aligned with responsible practice. Regulation will push us to consider how legal and policy frameworks respond when voluntary organizational ethics are not enough. Accountability will tie these ideas together by asking who is answerable for an AI system's behavior, who has the authority to correct it, and how affected people can seek explanation or remedy. So, as we begin this module, responsible AI should be understood as a foundation for disciplined decision making in technological development. It doesn't ask us to reject innovation, and it doesn't assume that automation is always harmful. Instead, it asks us to develop AI systems with a clear understanding that technical power creates obligations. Those obligations include careful design, thoughtful deployment, transparent governance, and continuing attention to the people and institutions shaped by the system's use. If we keep that perspective in mind, the rest of the course becomes a sustained examination of how artificial intelligence can be developed and governed in ways that are not only effective but also ethically and socially responsible. This second learning objective asks us to describe the core ethical principles that guide responsible AI systems: fairness, accountability, transparency, and human oversight. These principles are not decorative language added after the technical work is finished. They are practical standards that help organizations evaluate whether an AI system should be built, how it should be tested, how it should be explained, and how it should be governed once it affects real people. That bridge is what turns abstract ethics into concrete design and governance practice. They help us ask not only whether a system produces outputs, but whether those outputs can be trusted, challenged, justified, and improved. Fairness is often the first principle people associate with responsible AI because AI systems can affect individuals, organizations, and society in uneven ways. A system may appear neutral because it relies on data and mathematical procedures, but the data may reflect historical inequalities, incomplete representation, or patterns that are inappropriate for the decision being made. Fairness asks us to examine how outcomes are distributed and whether certain groups or individuals are disadvantaged by the system's predictions, classifications, or recommendations. Fairness is not simply a feeling that a result seems reasonable. It requires attention to the context of the decision, the population affected, the consequences of error, and the criteria used to judge whether the system is acceptable. Accountability connects the use of AI to organizational responsibility and ethical decision making. When an AI system produces a questionable or harmful outcome, it is not enough for an organization to say that the model made the decision or that the algorithm produced the result. Models do not carry moral responsibility on their own. The responsibility belongs to the people and institutions that select the system, define its purpose, approve deployment, monitor its performance, and decide how much authority it will have. Accountability, therefore, requires clear ownership, documentation, review procedures, and escalation paths when concerns arise. Without accountability, AI can become a way of distancing human decision makers from the consequence of the systems they choose to use. Transparency supports responsible AI. By making it possible to evaluate intelligent systems and their consequences. Transparency does not always mean that every technical detail must be understood by every person, especially when complex models are involved. It does mean that relevant stakeholders should be able to understand these systems' purpose, the kind of data it uses, the role it plays in decision making, its known limitations, and the reason its outputs should or should not be trusted in a particular context. Transparency is closely connected to trust because people are more likely to accept an AI supported process when they can see how the system fits into the larger decision structure. When transparency is absent, affected individuals may experience AI as a hidden authority that shapes outcomes without explanation. Human oversight completes this set of principles by reminding us that responsible AI should not remove human judgment from decisions that require ethical, contextual, or professional evaluation. Oversight helps protect people from harmful or unintended outcomes because it creates opportunities to review behavior, question unusual results, and intervene when automated outputs conflict with evidence, context, or values. This does not mean that humans must manually approve every action an AI system takes, because the appropriate level of oversight depends on the risk and context of use. However, it does mean that organizations should be deliberate about when humans are in the loop, when humans supervise the system at a higher level, and when automation is allowed to operate with minimal intervention. The more consequential the decision, the stronger the case for meaningful oversight. Together, fairness, accountability, transparency, and human oversight give us a way to evaluate AI systems as parts of social and organizational life, rather than as isolated technical artifacts. Fairness directs attention to the people affected by system outcomes. Accountability identifies who is responsible for design and use. Transparency makes evaluation and explanation possible, and oversight keeps human judgment connected to automated processes. These principles also reinforce one another. A system that is not transparent is difficult to hold accountable. A system without accountability may fail to correct unfair outcomes, and a system without oversight may allow small errors or hidden assumptions to become large harms over time. For this reason, responsible AI depends on the interaction of ethical principles, not on any single principle standing alone. This third learning objective asks us to analyze the societal and economic factors driving the global focus on ethical AI development. And that wording is important because the attention surrounding responsible AI did not appear in isolation. It emerged as artificial intelligence moved from research environments and specialized applications into ordinary organizational and public decision making. Once automated systems began influencing access to jobs, credit, education, healthcare, security, and public services, the question was no longer only whether AI could improve performance. The deeper question became how societies should manage technologies that can shape opportunities, distribute risks, and amplify existing patterns at very large scale. A major factor behind this global focus is the rapid adoption of automated decision systems. Organizations are drawn to these systems because they can process large volumes of data, detect patterns, reduce repetitive work, and support faster decisions. Those benefits can be real, especially when AI is carefully designed and used in a context where its limitations are understood. However, rapid adoption also creates pressure because institutions may implement automated tools before they have fully developed the governance practices needed to evaluate them. When AI systems spread faster than policies, training, documentation, or oversight mechanisms, organizations can end up depending on tools they do not fully understand. Public concern about bias and discrimination is another central driver. AI systems learn from data, and data often reflects the world as it has been, not necessarily the world as it ought to be. if historical patterns of exclusion, unequal treatment, or underrepresentation are embedded in training data, an AI system may reproduce those patterns in a way that appears technical or objective. This is why bias in AI can be especially difficult to address. The harm may not come from an openly discriminatory rule, but from a model that identifies statistical relationships that are socially problematic when used for consequential decisions. As people become more aware of this risk, they increasingly expect organizations to demonstrate that their systems have been evaluated for fairness and potential harm. The societal stakes are higher because AI now influences many sectors at once. In healthcare, AI may support diagnosis, triage, imaging, analysis, or resource allocation. In education, it may be used for advising, assessment, tutoring, admission support, or academic analytics. In finance, it may influence lending, fraud detection, investment decisions, insurance, and customer risk profiles. In security and public policy, automated tools may support surveillance, threat assessment, resource planning, or administrative decision making. The same underlying issue appears across all of these areas. When AI participates in decisions that affect human well-being, public trust depends on whether those decisions are fair, explainable, accountable, and subject to appropriate human judgment. Economic incentives also help explain why ethical AI has become a global concern. AI promises productivity gains, competitive advantage, lower operating costs, and new forms of service delivery. So businesses and governments have strong reasons to adopt it quickly. At the same time, the economic value of AI can create incentives to deploy systems before the social risks are fully measured. Organizations may focus on efficiency, scale, and market advantage, while underestimating the cost of error, reputational damage, legal exposure, or public backlash. Ethical AI development responds to that tension by asking organizations to treat trust, fairness, and accountability as part of sustainable technological development, rather than as optional additions after deployment. Growing regulatory attention reflects the need for stronger AI governance. Around the world, policymakers are increasingly concerned that voluntary commitments may not be enough when AI systems affect rights, access, safety, and economic opportunity. Regulation enters the conversation because societies need mechanisms for setting expectations, assigning responsibility, requiring documentation, and ensuring that high-risk systems receive appropriate scrutiny. Even when specific laws differ across countries and industries, the broader trend is clear. AI governance is becoming a central part of how institutions manage technological power. For our purposes, this means ethical AI is not only a philosophical concern, it is also an organizational, economic, and policy concern that shapes how modern AI systems are built and trusted. Analyzing these forces helps us understand why responsible AI is now discussed by engineers, executives, regulators, educators, and the public, rather than by technical specialists alone in practice. This fourth learning objective asks us to evaluate the potential benefits and risks associated with widespread AI adoption across industries. Evaluation is the important word here because responsible AI is not built on simple optimism or simple fear. It requires us to look carefully at what AI systems can make possible while also examining conditions under which those systems can create harm. In organizations, AI is used to support analysis, automate routine tasks, identify patterns, personalize services, and improve decisions. Those capabilities become responsible only when matched with careful assessment of impact, limitation, and context. One major benefit of AI adoption is its ability to transform business operations, public institutions, and everyday life by improving the way information is processed and used. Many organizations face volumes of data that are too large, too complex, or too fast-moving for traditional human review alone. AI systems can help detect trends, flag anomalies, generate recommendations, and support decisions that would otherwise require significant time and labor. In public institutions, similar tools can help organize services, manage resources, and identify needs. In everyday life, AI already appears in search, recommendations, navigation, translation, accessibility technologies, and digital assistants that many people use without thinking of them as artificial intelligence. Efficiency is one of the most visible promises of automated tools. When AI is used well, it can reduce repetitive work, speed up administrative processes, support more consistent decision making, and allow people to focus on tasks that require judgment, creativity, empathy, or professional expertise. In industry, this may mean faster quality control, better forecasting, improved customer support, or informed resource allocation. In education or healthcare, it may mean earlier identification of needs, better organization of information, or support for professionals managing complex cases. Responsible AI does not deny the value of automation. It asks whether that value is pursued with safeguards. At the same time, widespread adoption can create harmful or unintended consequences when organizations treat AI outputs as automatically reliable. Automated systems can make mistakes, and those mistakes can be difficult to detect when the system operates at scale or when users assume technical outputs are objective. A model may perform well under one set of conditions, but degrade when data changes, when the population shifts, or when applied to a context that differs from its original training environment. Even when the system is statistically strong overall, the distribution of errors may matter deeply. If the burden of error falls more heavily on particular people or communities, performance averages can hide serious ethical problems. Bias and discrimination are among the most important risks associated with AI adoption. These risks can emerge from historical patterns in data, underrepresentation of certain groups, flawed assumptions during development, or decision rules that appear neutral but have unequal effects. In hiring, finance, healthcare, or education, biased outcomes can affect access, opportunity, and trust. Over time, repeated automated decisions can reinforce existing inequalities by making disadvantage appear like a pattern of individual risk or poor fit. That is why responsible evaluation has to consider immediate outcomes and broader social effects. Another risk is inadequate evaluation of AI system impacts. Organizations may test whether a system is accurate, but fail to ask whether it is understandable, contestable, insecure, fair, or appropriate for the decision it supports. They may monitor technical performance while overlooking how users actually interact with the system or how affected people experience its outcomes. This matters when AI becomes embedded in workflows because people may gradually defer to automated outputs even when they should exercise independent judgment. Responsible evaluation must therefore continue after deployment through monitoring, documentation, review, and clear procedures for correction. So, when we evaluate the benefits and risks of widespread AI adoption, the goal is not to reach a single conclusion that AI is beneficial or dangerous in general. The responsible question is more precise. Beneficial for whom? Risky for whom? In what context? With what safeguards? And under whose accountability? AI can expand human capacity, improve services, and support better decisions, but it can also scale bias, obscure responsibility, and produce harm when organizations move too quickly or govern too weakly. This balanced evaluation frames AI adoption as a strategic and ethical decision, not just a technical upgrade. Responsible AI asks organizations to innovate while remaining accountable for the human consequences of the systems they build and use. Human oversight recognizes that automated tools can support decision making, but they should not erase human judgment, professional responsibility, or ethical accountability. In responsible AI, the presence of a model does not remove the need for people to ask whether the system is appropriate, whether it's performing as expected, and whether its consequences remain acceptable. Human judgment remains necessary even when automated tools appear highly efficient. Efficiency can be valuable, especially when organizations are managing large amounts of information or repetitive decision processes. But speed is not the same as wisdom. An AI system may identify patterns quickly, rank options consistently, or produce recommendations at scale, yet it may not understand context in the way a human professional does. It may not recognize when a case is unusual, when a data point is misleading, or when the consequences of a decision require caution beyond what a prediction score can provide. Oversight helps ensure that humans remain attentive to these limitations, rather than treating automated output as a final answer. Responsible AI also requires ongoing monitoring of system behavior and impact. A system that performs well during testing may behave differently after deployment because the real world rarely stays fixed. Data distribution shift, user behavior changes, organizational priorities evolve, and new populations may be affected by the system in ways that were not fully anticipated during development. Monitoring allows organizations to detect performance drift, unexpected errors, unfair patterns, or changes in how people rely on the system. Without monitoring, an AI system can continue producing outputs that appear routine while gradually becoming less reliable, less fair, or less aligned with the purpose for which it was originally approved. Oversight supports accountability when AI affects people, organizations, and society. If an automated tool influences a decision about access, risk, eligibility, service, or opportunity, someone must remain responsible for how that tool is used and what happens when it fails. Accountability requires more than naming a department or assigning ownership on paper. It requires procedures for reviewing concerns, documenting decisions, escalating problems, correcting errors, and communicating with affected stakeholders when appropriate. Human oversight provides that practical structure through which accountability becomes real, because it creates points where people can intervene, explain, revise, or stop a system rather than allowing automation to operate without meaningful challenge. Ethical decision making keeps humans involved in AI governance and deployment. This involvement should not be confused with casual supervision or symbolic approval. Meaningful oversight requires people who understand the system's purpose, its limitations, the context of use, and the ethical stakes of the decisions it supports. In higher risk settings, especially where decisions affect rights, safety, financial access, education, healthcare, or public services, oversight may need to be stronger, more frequent, and more formal. The level of human involvement should match the seriousness of the potential harm. A responsible oversight structure also asks how humans interact with AI in practice. People can become too dependent on automated recommendations, where the system's output is accepted because it seems technical, efficient, or objective. Good oversight therefore includes training, clear boundaries, documentation, and decision procedures that help users know when to rely on the system, when to question it, and when to seek additional review. Human oversight is not simply the presence of a person near the technology. It is the design of a decision environment where human judgment can operate effectively. As we close this module, human oversight should be understood as one of the central safeguards that makes responsible AI possible. AI systems can extend human capacity, but they do not eliminate the moral and organizational responsibility attached to consequential decisions. Ongoing oversight helps organizations monitor performance, identify unintended harm, preserve accountability, and keep ethical judgment connected to technological development. Responsible AI is never only about building a model that works, it's about maintaining a system of human responsibility around that model so the organization remains answerable for how AI shapes people, institutions, and society.